And how are we doing, folks? It is now Monday night, starting out another week, and we're talking some QoS, talking some QoS shaping. Hope you're having a good Monday. Hope everything's going well. It's going well for me. Um, I am getting into. I really enjoyed yesterday's stream, I should say. Sunday stream was awesome. Had some great interaction with the chat. Helped me get through some calculations on the shaping formulas, which is great. I have some more feedback today as well, which I need to go over actually. We're going to do that in a minute, yeah, but we're going to get right into it. Not much to vlog about. Typical Monday. Worked out this morning. My wife's just starting keto, which is great. I've been learning some keto cooking to help her out. And that's been going well. She's doing so far so good. And did some great network lessons shaping yesterday. We're going to continue on that today. The same lesson. It's an extensive lesson. We finished the first example, and today I want to go over, I think it has one or two more examples of shaping. Same thing, just sort of repetition for emphasis, right? And I've got the same link here yesterday that I found, actually one of the viewers found from Routing Bits about a more accurate formula. And I want to check, actually, I got some feedback on the YouTube video, and I want to look at that now. I just had a chance, I only really had time earlier to just glance at it. But yeah, there's a comment here. Someone mentioned, have you looked at Pi-hole? Not sure what, I think Pi-hole, isn't that a Raspberry Pi? I'm not sure what video that is. That is a comment on one of my videos. I need to go back and look. Let's see. Someone, though, had a comment. Oh, that was on Twitter. That's right. Someone sent me a DM, I think, on Twitter about further revising this formula a little bit, which we're going to take a look at. Yeah, it's just been real busy today, folks. Message. We're, by the way, very rapidly approaching. Oh yeah, ARC SCZ. Thank you. All right. Okay, so I was one of your viewers. TCMS divided by 1,000, right? Okay, great comments. And that was from, I believe, on stream, it was Sherwin, who is really helping out. Yeah, and really it's all about lining up your units of measurement, right? And he makes some good points here. Thank you very much, Sherwin, for your DM on Twitter and the information. And as a matter of fact, in this blog, it does allude to the fact that essentially when you're talking about TC, it is divided by 1,000. So yeah. Yeah, I guess there's a couple ways to do it, and the main thing is to ensure that we are lining up all of our units of measurement, whether that be bits or bytes or time, etc. So we've got the same lab today, folks. Same basic lab. We've got we've got a client, a server, and two routers. And I think right now most of the traffic is traversing GI02. So I've got iPerf running over here, iPerf S. And yesterday we successfully got through the network lessons, the first lesson. By the way, this is not my lab. If you want to see the information on this lab, all the configurations, how to build it, the explanations, the video, the packet captures, check it out at networklessons.com. They have a subscription basis that you can use to obtain access to it, which is what I have. And I don't show that on screen, but I'm just showing how I sort of work through the lesson. So what it's saying is it's going to try another example here, and let me write out. I can just type code actually. Yeah. So there's another example here it wants us to go through. And this time it's going to shape to 50% of the available bandwidth. And of course, well, actually on this, so in this lab, it's setting a clock rate on a serial interface, which we're not doing, right? We're using a gigabit interface here. So in order for me to achieve the same sort of result, well, we're just going to imagine that this is a 512K circuit. But we're going to shape to 256. So in this case, we're going to shape average. I think yesterday it was 6.4. So we're significantly increasing the shaping threshold here, right? And we're essentially targeting. So let's say, for example, that our provider has told us we have a 1 gigabit circuit, but our provider has told us that they're policing at 512K. And so what we want to do is, let's say they're policing at that, not right here, but potentially farther down the stream, right? Because that would be a big waste, right? But let's say downstream they're policing an aggregate of 512. So we want to shape here at 256, which would essentially be half of that. Okay, so what we want to figure out here is if we do 256, then what will the rest of our formula look like? What will our BC be? If we tell Cisco the shape average is 256, what will the formula be? So let's look at our formulas again. And let's say that we know the CIR. So CIR formula equals let me find it again. Yeah, so CIR equals BC divided by TC divided by 1,000. So this is our formula from yesterday, and we have not been given the BC to use. All we've been told to do is configure the shape average of 256. So Cisco will actually calculate the BC for us and the TC. It does not show us the TC, but we want to solve for TC. So we're going to go over here on our router 1. Oops, didn't mean to do that. Trolling. It's trolling me. We got a little troll sitting on a router. Okay. Show run interface chat02. Show policy map shape underscore average. Okay, so what we're going to do is we're going to change the CIR here. We're going to say policy map shape average, and we are doing class iperf. And we're going to shape average. So now if we do show policy map interface chat02, okay, to set the BC of 1024. So let's turn this around. We know what the CIR is. We want to find for TC. So TC equals BC divided by CIR times 1,000. So in this case, our burst, committed burst in bits, not bytes, 1024 divided by a CIR, and we are aiming for, in this case, yeah, CIR is 256.123, 256.000. I know I say 123. That means how many zeros? Times 1,000. And let me see if this agrees with the lesson here. So TC equals, look at that. So this is 4 milliseconds. And that's interesting because that is the smallest unit you can use, I believe, on this iOS image, is 4 milliseconds. So let's see if that is correct. Once again, the Cisco iOS sets the BC value so that we end up with a TC of 4 milliseconds. All right, let's send our client. Let's send some iPerf traffic. iPerf C192.168.2.2. Has to be uppercase P. Oh, interesting. Okay, the next one they have us. This is almost like as if we're using serial links, right? We did 64K. Now we're doing 256K. And in a moment, we're going to actually switch to 1 megabit per second. Ooh, 1 megabit, right? It's all right. We're going to get our results here. So interesting, right? Or some 232 kilobits per second. Close to 256. Good. All right, let's bump it up. Now we're going to bump it up to 1 megabit per second. And the command is 1M. Let's look at that command, because that is a little different. I'm used to entering, let's just copy, we're going to say policy map shape average class is iPerf. And we're going to do shape average 1. Okay, check it out. Postfix. You can either do kilobits, so you can do bits, or you can do kilobits, megabits, gigabits. So we're going to do 1M. Now let's do show policy map interface jazz02. Okay, BC is now 4,000. So let's find out what our TC is. In this case, it's going to be 4,000. Times divided by 1,000,000 times 1,000. Let's see what our TC is. I'll bet it's 4. Look, you can almost tell, right, that it's going to be 4 still. Yep, same. So it's still using 4 milliseconds. Now let's run our iPerf. and see what we come back with. Okay, so this is interesting. Now the lesson is saying, first of all, it's saying we cannot configure the look at this, 902K. So a little shy of 90% of 1 megabit per second. So it works. Now the lesson is saying we can't really manipulate the TC. Cisco sets that. We can't manipulate that value, but we can control the CIR and the BC, thus indirectly influencing TC. So it's posing to us now, let's say we have a requirement that we have to set the TC to 10 milliseconds. Interesting. Okay, so it is at 4. So if we want 4, because the formula is TC equals BC divided by CIR times 1,000. And we can set the BC Interesting. So here it's saying, yeah, use the BC formula. Okay, BC equals, because this is what we want to calculate for. That's true. So BC is going to equal, we're still using 1 megabit per second. And we want the BC, or the, well, the BC equals TC times CIR, right? It's actually, I think. Yeah. Or the other way around, right? BC equals CIR times TC divided by 1,000. So we want to make this, we already know, it's 1 megabit. So it's 1, 1, 2, 3, 4, 5, 6 times the TC, we're targeting 10 milliseconds. So this should tell us what the BC should be, right? So let's say 10 divided by is 0.01. So this times 1,000,000 is 10,000 bits. So let's set this on the router and check it. We will say, let's see, lossy map shape average, class hyperf, shape average, 1 megabits per second, and the bits per interval sustained, recommended not to configure. Well, we've been given this requirement. So we want to put 10,000 bits here. All right, now let's see if we got it. Well, it's not really going to show us that, right? But let's do our formula here and see if we got it right. TC equals 10, 1, 2, 3 divided by times 1,000. And this should get us to 10, which would be 10 milliseconds. And it is. So, okay, I think I'm getting the hang of this. Great lesson here. All right, we have another challenge. we want a TC of 125 milliseconds. All right, so our formula is going to be BC equals, and I do need to learn these. I'm going to memorize these. Yeah, the CIR times TC divided by 1,000. So this would be 1 megabits per second. So 1, 2, 3, 4, 5, 6 times 125 divided by 1, 2, 3. And let's see. So 0.125 times is 125,000 bits. So let's plug that in. One megabit per second still. And our first committed is 125.123. Show policy map interface GI02. Okay, it is there. Let's go the other way around and see if it works. So TC equals on the BC divided by CIR times 1,000. So the TC would be 125. No, sorry. BC 125.123 divided by 1,000,000 times 1,000, 125 milliseconds. And there we go. Good stuff. That's it. You have now seen how to configure shaping, how to influence the TC by setting different BC values. Okay, so this is average shaping. This is a single rate, which is a committed information rate. What I will be doing the rest of the evening is going over peak rate of shaping lesson. I need to do a little research on that before I lab it, so I'm going to do that off stream. But I just want to say, happy Monday to everyone. Hope you have a great Monday, and let's set our goals. It's getting towards the end of March. I'm a little behind on QoS, but I'm okay with that. I'm making progress. I'm beginning to learn and understand, which is fine with me, as long as we're continuing forward. I knew QoS would take a while. So we're going to continue with that tonight, and thanks for joining. Hope you have a great rest of the week. But don't forget to tune in here on the Land Tamer stream. We're here every night, Monday through Thursdays, 7 p.m. Eastern Time. And also, it varies on the weekends, and I'm off on Fridays. But definitely, follow us here on Twitch to get notified whenever new streams are broadcasting. And of course, you can subscribe to me on YouTube, Instagram, and Twitter. And we'll see you back here tomorrow night, same time, here on the Land Tamer stream. Have a great night, folks.